Hi there, this is Jacob Nash, and this is the last prerequisite review video that I'm going to do, and it is on graphs and transformations. I'm not going to go over every single one, but just the most important ones, okay? Which are pretty much the ones that you learned. Obviously, we already talked about the trigonometric ones in the last video. So the first one is, and I'm just going to use f of x instead of y right now, okay? F of x equals x. Oh, well, luckily, that's pretty easy. But, we don't want to just do like a general graph. Like, how about we actually make it look right? So let's just say, all right, how we can do this, the easiest way is just take any x value and just see what happens for y, all right? Let's say 0, okay? X is 0, y is 0. So the easy thing about this one is whatever x is, y also is, okay? So that means 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, -1, -1, da, da, da. You get it, bam. That's obviously not straight, but pretend like it is because that's our linear function. Obviously, there are transformations we can do, and mx plus b is a very common addition to this that we probably remember, hopefully. B is the y-intercept, so let's say we had x plus 3, then obviously if x was 0, y would be 3. That's why it is the y-intercept, okay? And then it would change, transform, it would be higher up instead. And the slope just means how steep is the line, and however that is, if it's a big slope, it's going to be steeper. If it's a smaller number, it's going to be less steep, more like that. That's pretty much review. And once again, I almost said once again, make sure that you watch other videos I've made if you don't understand that. Next one we're going to do is probably the second one you would have learned maybe 5 years ago, however long it was since you took algebra. X squared, which is our quadratic, our fun parabola. And for this one, let's see what happens. 0, 0. 0 squared is 0. 1 squared is 1. 2 squared is 4. So, what do you know? Not linear anymore. 3 squared is 9. It keeps getting steeper, and then it's mirrored on the other side. Because why don't we ever go down here, huh? Because anything squared is never a negative number. But a negative number squared, you are allowed to do that. That's why it can be at negative x. Oh, what do you know? And obviously, we know we have transformations. We know we have, hopefully, remember there's different ways we can display this graph. There's different ways we can find our zeros. In this case, we only have 1 0. 0, x-intercept, root, all mean the same thing. If you recall, you can do a lot of different things to find that, quadratic formula being one of them. Ooh, don't like to remember these things, do we? That's okay. This is not my strongest interest either. I just make these videos. Okay. Let's do this. Oh, what about that? Okay. Well, 0 cubed is still 0. 1 cubed, 1. 2 cubed, 8. Woo! Oh, that's even steeper, but is it like this? No, because if a negative number is cubed, it can still be negative. And it in fact is. How come? Well, that's not even really what this video is supposed to be about. But obviously, a negative times a negative is positive, but if it's times another negative again, still negative. That's why. So instead, it's mirrored, but like that. So It's kind of like a snake. There we go. Not too hard, not too hard. These things really aren't that hard if you get down to the juice of it. Okay. Let's do square root of x next. Can't decide which one's to do. This one's a little bit interesting. Okay, square root of 0, 0. Square root of -1. Oh, not possible to have anything in these three quadrants. How come? Because you can't take the square root of a negative number, and the square root of any number never could be negative. Sorry that I'm getting a little bit more hyped up in this one, but that's just how it is. Square root of 1, 1. Square root of 2, well, we don't really know what that is off the top of our head, so let's just go to square root of 4 is 2. Square root of 9, 3. So it's kind of like a little guy like that, and it doesn't go into other quadrants. It takes so long. Don't worry, I'm about to have my thing. On the next video, well, maybe not the next one, but on a very soon video, I will have my iPad back. Cube root, don't really need to do that one, but it's, yeah, don't really need to do that one. That's not as important. And if you're wondering, if you ever wondered, why do we never do x to the 4, x to the 5? Well, those just aren't that relevant. That's why. We're not going to talk about those right now. 1 over x. Well, this one's a fun one. It has, if you recall, not an ability for x to be 0. Why? 1 divided by 0, not a thing. Or not a thing. I need to stop saying that. Undefined. This one, it looks like this. Oh, well, let me just say why, because we need to know why. All right. X is 0, not a thing. X is 1, 1. X is -1, -1. X is 2, 1/2. X is 3, 1/3, but keeps getting closer, but it never actually touches it. And kind of like this on this side. Same thing over here. It's not to scale, but this is roughly what it looks like. All right, I'm just going to need to do a new thing after that. That would take too long to erase. All right, f of x, let's see. What's the next one that we should do? We've already talked about the exponential and log, so I'm not going to do that right now. That's all we need to do. I pretty much already talked about all the major ones on these prerequisite videos. Now, the important thing is we need to talk about transformations. Well, the way that I taught it before was specific to each one, but you can actually just have basic rules that apply to all of them. So we got to think about what can happen to make it go up, down, left. I might have well just written the first letters, whatever. Left, right. The other two major things I guess that we can do is x. I don't feel like writing the full thing, sorry. But that's supposed to mean x-axis reflection, y-axis reflection. So let's see, what do we do to make all these happen? Well, for this, so first of all, let me just highlight in red which ones of these apply to x. Huh? How come? Well, I will say that in a minute. And that might not be the very best way to describe this, but I'll explain in a second. These are the y ones. So what do I mean by this? Well, for all of these, let's just write f of x equals x to start. Actually, that was going to take too long, so actually I'm just doing this. So if we wanted it to be up, what do? We just have to add a value, but it has to be added to the y. So meaning that if there's something like this, it can't be under the square root. That's just an example. So it's not, it might be kind of confusing for me to explain it like this. So that's why it might be a little bit better to understand the other way, which in that case, just watch the older videos I have if you need more information. But no matter the case, this has to be kind of on the most outside that it can be. So whatever we have here, I mean, what's another example? Like if we had an absolute value, which, sorry, I forgot to draw that. That's another kind of important one. That's like a V. But it needs to be outside of whatever thing there is so that it's applied to the y. If you want it to go down, obviously subtract. However, if you want to go left or right, this is where things get a little bit strange, if you remember. If I wanted to go left, I actually have to add something to it. How come? Because it's the opposite of what you would think, because this is really what we're looking at. So if, let's say, x plus 4, it's going to go left 4. And think about it. If the original value was 3 plus 4, but when you, like, think about it like how when you set things equal to 0, when you flip it out around to the other side, then it ends up being negative. So that's the reason why this is like this. But this, in this case, would need to be under the square root or in the absolute value thing or whatever. It's applied to the x. And obviously, if you want it to, if you want it to go to the right, you would subtract. So that's opposite of what you would think. Now reflection, and we're going to look at some more specific examples, so it'll make sense. A reflection across the x-axis is something that actually has to be done to the y. So let's just have an example here. What's a good example? How about this? If you want this, then there's going to have to be a negative sign for a reflection, but it's got to be outside of the thing where the x is. So it has to be over here, not in here. So that's why I'm saying applied to the y. It's applied to the y, not to the x. If you want an x-axis reflection. If you want a y-axis reflection, then you would put it in here. So that goes to the same thing for any sort of parentheses or enclosure you may have. In or out matters of which reflection you want. So we're just going to look at an example here. I'll just make one up. So how about f of x equals negative, and this isn't actually even, we're not actually talking about in here the compressions or extensions, not really extensions, but we're not talking about that in this video. But if you want to know about that, if you need to or don't remember, then please watch a different video that I have of that. Okay, so what would this mean? This is a good example. So let's just do this, okay? So we know what it would originally look like. It would be like that. But we have to also do these in a different order. So first, you have to do your lefts and your rights. Then you do your reflections. Then you do your ups and downs. This is important because it can result in different looking graphs. So let's first do the left or right. Well, we know it has to be, applied to the x. So it has to be the number that's near the x, not that, this. And -5, that actually means right 5. So dun, 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 we're over here. All right, next thing is reflection. Reflection, this is what is affecting the y, so it's actually an x-axis reflection. That makes sense because the y values change if you reflect over the x-axis. That's why it seems backwards. So now instead, kabam, it just reflected over the x-axis. Now it's down. Last thing, that actually means up 3, so 3. Oh, I should have done this first. 3. So we could effectively know where our vertex is because that's considered vertex form. And there you go. Not that hard. And I'm not going to give any more examples than that just because it's supposed to be a prerequisite. Please don't be mad at me. But I do have a different video about reflections, and I'll put that in the description. And it goes into way more depth than this. But that's it. And now we're ready to begin.